Okay, so today's lesson is about rational expressions. Okay, this is another topic that involves factoring. So as I said before, factoring is a very useful tool in algebra. So one of the applications of it we saw last time when we solved quadratic and cubic equations. Another application today is using factoring to deal with rational expressions. So we're going to learn how to, we're going to first define them, then we're going to learn how to simplify these expressions, multiply and divide them. And in another class, next class, we're going to see how to add and subtract these rational expressions. So first we're going to need to define these expressions. So basically the easy answer is a rational expression is just a fraction. Okay, so a rational expression is a fraction. Okay, so the only thing that distinguishes these fractions from the regular ones like 2 over 3 or negative 1 over 5 is that these fractions are made with polynomials. So it's a fraction made with a couple of polynomials. So for example, polynomial p over polynomial q. So this is basically what a rational expression is. It's a fraction made of these of polynomials. Here could be a monomial, trinomial, binomial, same thing here, could be any sorts of polynomial. And of course, with fractions, with any fraction, the denominator can't be 0. As you know, we can't divide by 0 because that would be an undefined value. It's not our real number. So that's basically all there is to it for a rational expression. A fraction made of polynomials. That means it has variables in it, here and here, x's, possibly x's and y's. And make sure the denominator is not 0 because that would be something that's undefined. Okay, so that's basically the definition of a rational expression. Let's write some examples of them. Could be, for example, 1 over x. That's a rational expression. This is a monomial. You can also consider this a monomial, so that's a quadratic, or that's a rational expression. It could be something like this. Or it could be something like this. Let's say x to the second minus, let's say, 25 over x to the second plus 5x, for example, or 6x plus 5. And so on. So we have a binomial here over a trinomial. We have a binomial here. Okay, so that's basically all these are rational expressions. Again, they're just fractions made with polynomials. And we're going to see how to do all sorts of operations with these, including simplifying, multiplying, dividing, adding, and subtracting. And later in another class, following class from now, not next class, we're going to see how to solve equations involved in these. For example, we're going to turn this into some equation. We're going to see how to solve this, okay? But that's for a later class. We first need to learn a lot of details about these before we can solve equations involved in it. Okay, so that's your definition. As always here, x can't be 0. Okay, that's the definition here. So x can't be 0 in this expression. Could be any number because we don't want to have 0 here. Over here, we don't want x to be 0. That means x can't be what? For this one, the denominator can't be 0. Okay, whatever the denominator is, it can't be 0. That means x can't be what? What value of x would give you 0?
-2.
That's right. Would be negative 2. You subtract 2, subtract 2. You solve them just like you solve equations. and this. So for this expression, you can plug any x except for this one. Just like we saw with functions, the functions have domain of definition, means what values of x are allowed and what values are not allowed. So that's what the domain is. So these are undefined here. Over here, in order to find the undefined values, you first want to factor this. So the denominator can't be 0. It means this can't be 0. Then you factor it. What numbers do we use here? To factor this expression, we need two numbers that multiply to 5. Same numbers add up to 6. What numbers do that?
5 and 1.
That's right, both 5 and 1. So because 5 times 1 is 5, so 5 plus 1 is 6. So whenever you want to find the undefined values of any denominator, first factor the expression if it's not already factored, like here and here. Now, we don't want this to be 0, so that means this can't be 0 and this can't be 0. 6 plus 5 should not be 0. And both of them, not or, and the other factor can't be 0 as well, because again, division by 0 is not allowed when we deal with real numbers. Then you solve this, that means x can't be 5, can't be negative 5. And here, x can't be what?
Negative 1.
Right? X can't be negative 1 because we don't want this to be 0. If either one of these is 0, the whole thing will turn into 0, and therefore the whole expression will become undefined. So we don't want to have that, so we're going to avoid these numbers. Whenever you plug the numbers here for whatever reason, whether it's a function or something, you don't want to use these numbers, negative 5 and negative 1. So these are undefined. So all these numbers are undefined. We don't want to use them, and we can't use them actually. Okay, so the first step, we want to look at a rational expression. You want to see what the domain is, what the domain of the definition. For this one, you can use any number except 0. The domain here is all real numbers except negative 2. For this one, we can't use these two. All right, so now that we know what rational expression is and what's the domain of them, let's see how to simplify. So simplifying rational expressions. Just like with the regular fractions, when we have, for example, 15 over, let's say 35, this is a regular fraction. We can reduce it, right? We can turn 15 into 3 times 5. Or we can turn this 35 into 7 times 5. And what happens next to simplify this? What happens in order to simplify this regular fraction? You can cancel the 5s, and the fraction turns into 3 over 7. So this one is much simpler than this. Okay, so this is a real number, fraction with the real numbers. We turned it into this. That's much simpler. It's what we call reducing to the lowest terms or simplifying. We can do the same thing with rational expressions. We can factor them like this and then cancel out what's common between the two. Very simple. Here's one here. Let's say you have x to the second, or actually maybe something like this. X plus 1, and maybe some 8, and also x plus 1. So let's say you want to simplify this rational expression. What happens exactly? Everybody, what happens to this expression to be simplified? I'm talking to everyone.
X plus 1.
Engage,
X plus 1.
X plus 1.
X plus
3x.
That's right. So these cancel out. So what's left is just
3 over 8.
8. So after simplifying a rational expression, you may end up with a real number like this, or the x might still be there. So you try to simplify it as much as possible. So that's what we mean by simplifying a rational expression. Basically, we cancel out the common factors. You may need to factor first to do this. If it's already factored, you just go ahead and cancel out. So as we go, we're going to see more complex examples. Here's another familiar one that we have seen before. So when you have, for example, x to the third over x to the second, what is that equal to?
3 over 2.
Say that again?
3 over 2 if we cancel the x.
Nope, you can't just cancel the x here because these are powers, not factors.
Wouldn't it just be x?
X over 2.
Because
Okay.
Oh, wait.
minus
X over
2 is
3.
1, so
On
the
the
x1.
Exactly, we subtract the powers. 3 minus 2 would be 1. That's another simple example with rational expressions. Let's look at another one here, another example. So let's say you have x minus 2, and you have 3x minus 6. And the question is, simplify this rational expression. What do you think we do to simplify this rational expression?
You cross out the x and then it's 2 over.
Okay, so
2 over 3.
here's the problem. We can't just go ahead and cancel the x and cancel the x, reduce 2 and 6. The reason why, because this is not factored. It has to be multiplications here. Here, the reason we did that, because we had multiplication and multiplication. So before you can cancel the common factors, as you saw here earlier, so multiplication and multiplication. If you had 3 minus 5 here, for example, and 7 minus 5, you can't just cancel the 5s. You need to turn it into a product of factors. Once you have all products on both sides, then you can cancel out any common products or factors. So with rational expressions, always factor them first before you do anything else, including simplifying, adding, subtracting, multiplying, and dividing. So, and as always, as I said before, factoring is very important. That's why I told you to review all the methods of factoring we learned in the last couple of lectures before the midterm. So as always with factoring, you try GCF first. Always try that first. If that doesn't work, then you resort to another method. Could be grouping. Okay, could be binomial factoring with a difference of 2 squares, or it could be trinomial factoring, as we did here earlier with this. So both, we're going to apply that both to the top and the bottom. For the top, do we have a GCF? There is no GCF. There is no trinomial or grouping. It's not a difference of 2 squares. That's basically already factored. Okay, so we can leave that like that. What about this one? How do you factor this? Is there a GCF?
So it's going to be 3x.
The GCF? Is there a common factor here? What is it?
Minus negative 3.
No, what's the common factor here? We want to factor this.
2.
What is it?
2, 3, teacher.
3. 3 is common. Open
3.
That's right. Divide by 3x by 3 is x.
X minus 2.
6 by 3 is 2. Again, factoring is very, very, very important. I strongly recommend you go review all the methods of factoring. You'll learn there's 4 of them. They're summarized here because the rest of the class, the semester will 80% be based on factoring. We're only going to learn some new concepts, but most of it is based on factoring. All right, now that we factored both, what do? We couldn't factor here, but we factored this. What happens next? What happens now? Again, we're trying to simplify. In other words, what cancels now after we factored?
Oh, negative 2x. I mean x negative 2.
Basically, we're going to cancel the common factors. We have x minus 2, x minus 2. So you can think of this as this, because 1 times anything is itself. So you can think of it as 1 times this. So you see that that factor is common. You could cancel this factor, cancel this.
3.
What's the result?
3.
Not 3. Keep the same order of the fraction. What's left at the top?
Or 3x.
1.
Or 1 over 3.
1, 3.
1 over 3. So it's not 3, it's 1 over 3. And that's it. So this
So,
rational.
Professor, I have a question. Can it just be 3s? Or does it have to be 1 over 3?
1 over 3 and 3 are two different numbers. 1 over 3 is 1/3, which is 0.33. And 3 over 1 is equal to 3. So it's not the same. 1 over 3 is totally different from 3 over 1. So keep the same order of the fraction. If you had 3 here and 1 at the bottom, then you could say 3 over 1 is 3. But here it's 1 over 3.
So if we're taking a test, it has to be 1, like the same way you're doing it now.
That's right.
Okay.
So basically this expression turns into this. As you can see, that's the reason why factoring is useful, because it makes things a lot easier. So instead of having an answer like this, it's the same as this method. So there's no reason to leave it complex like this, when we could simplify it into this. So this is 1/3. So instead of, let's say you want to ask someone for 1/3 of their whatever, let's say 1/3 of their pizza, instead of saying, it's much easier to say, give me 1/3 of your pizza, instead of saying, give me x minus 2 over 3x minus 6 of your pizza. That's just complex. And, you know, with math, we try to make things easier. We try to make life easier, not the opposite. Okay, so that's one way to simplify. You could also have, let's go back to this one here. It's a lot of interesting and complex. Let's see how to turn that into something simpler, if possible. We have binomial. We have trinomial. As always, when you simplify rational expressions, what's the first thing you do? What is the main step called? We need to. What was that step from here to here? Again?
S.
Factoring.
S.
That's right. Due to factor. So factoring is very important. That's what we did here. Once we factor rational expressions, things get a lot simpler, as I said. So now, how do you factor the top? Binomial. There's no GCF. So we're going to try binomial factoring. What is that equal to? X to the second minus 25. I did this before the next. How do you factor the top? What is it equal to?
S.
X minus 5.
Minus 5.
And X?
S plus 5.
5. Okay, so again, we did the factoring before, so that's something you will have to review. The bottom one, it's a trinomial. We did it here earlier. So it's x plus 5, x plus 1. Well, please mute your mic if you have background noise, and only unmute it when you respond. All right, so we factored here and here. What do you do next? What happens next to simplify this?
S plus 5.
You're cutting out. I'll see if I can hear you well. Everybody else, what happens after this expression? I'll see that. you're cutting out.
Like x,
So x plus 5
x
S,
second power.
5.
S plus 5.
So we're going to have x minus 5 divided by x plus 1.
That's
S
right. We cancel the common one. It has to be the exact same way. X plus 5, x plus 5. What's left is just x minus 5 over x plus 1.
Yes.
And that's it. We can't do anything else. Again, we can't just cancel this x and this x because it needs to be multiplications here in order to cancel that out. So that's basically it for that expression. So it was kind of longer and a little more complex, but now it's much simpler with this, and you can't do anything else. That's your final answer. For this one, it was 1 over 3. So you may end up with a fraction without variables, or the variables could still be there, but it's not a problem. Just simplify it as much as possible. So that's basically the idea of simplifying rational expressions. Again, factor all and then cancel common factors. So keep that in mind, and we will have to simplify every time, basically, even when we have to factor, even when we add, subtract, multiply, divide. So simplifying or anything else with the rational expressions will involve factoring. Any questions, everybody, at this point?
No questions, thank you.
Okay, everybody else? Any issues? That's okay. All right, so let's see what else we need to do here. So let's go over to number 3. Now we're going to see how to, let's do the multiplication of rational expressions. So this, again, you may say simplify or reduce. Okay, reducing to the lowest terms means the same thing. Okay, and let's see how to use that to multiply. So multiplying rational expressions. Okay, multiplying rational expressions. Just like with regular fractions, let's say 1 over 2 times 3 over 5. Again, the concept of rational expressions is very similar to regular fractions that we've learned before. Whatever we can do with regular fractions basically can be done with rational expressions, because rational expressions are just fractions, as I said. Fancy type of fractions, but all the rules of regular fractions apply to them. Before we multiply some rational expressions, let's see or review how to multiply regular fractions here. What is this equal to, or what do you multiply, or which way do we multiply these two fractions?
Three.
3 and
Mm-hmm.
what else?
3 and 2.
Nope, not 3 and 2. How do you multiply fractions in general? What is this? What is this equal to?
5. No.
3 over 10.
3 over 10. So 1 times 3.
Yeah, just okay. I thought that we have to like it's gonna be 2 over 1 multiplied by 5 over 3, but we're doing that when we divide, right?
Mm-hmm. You do that for
yeah, for division. Yeah.
for multiplication of fractions.
Yeah, just like
Multiply straight across. That's how we do this. So this will be 3 over 10. Right? And sometimes, so that's one example. Sometimes, and reduce this if possible. Try to simplify it. Nothing goes into 3 and 10 other than 1, so it stays like that. And whenever possible, try to simplify your fractions. Let's say So you have this multiplication here. So we're gonna use some regular fractions, then we'll see how to apply the same concept to fractions like this, rational expressions. So what do you think happens now? We want to multiply these two. What do you think we do now? We do first to multiply these two.
So
Okay.
16 and 8.
4 and 8.
What's the word we use? What's the verb?
Simplify.
Simplify.
Simplify, teacher.
Exactly. So simplify. So you don't want to multiply 15 and 16, 8 and 25. It's going to be a lot of work. You have to do the multiplications, and then you're going to end up with a large fraction that you still have to simplify. So better simplify first, okay? Before doing anything, always simplify your fractions or rational expressions. And to do so, you see if you can simplify this way and here. If not, we do what we call cross simplify, not cross multiply, cross simplify. For example, you look at 8 and 16. What's the highest number that can go into
8.
What is it?
8.
8. So 8, you can say 8 times 1. And 16 we can turn into what?
Before, teacher, no?
8 times?
2.
We want to have a common number here, 8 and 2.
Oh.
We're going to cancel later, we're going to cancel these two 8s. We're going to end up with much smaller fraction. Same thing here. What's the highest number?
5.
Okay, 5. So 15 is 5 times.
5 times 3 and 5 times 5.
That's right, 5 times 5. So we kind of factored it now, broke it down into multiplications with the highest number that can go into the numbers. We could have used 2 here or 4, but 8 is the highest one. So we want to use the highest number possible. So now before multiplying again, we want to get rid of all the common numbers, either this way, if you have anything here, or cross simplify, not this way. You can't cross simplify this way. Okay, so it has to be 1 from the top against 1 from the bottom. So we have 1 from here against 1 from the bottom, and 5 on the 5. Now it's much easier to just times what's left. So we have 3 times 2. And 1 times 5. Which is basically 6 over 5. So we didn't even have to do the actual multiplication. Okay, so that's again the reason why we need to simplify. Always simplify your fractions, whether it's regular fractions or rational expressions. You want to make them smaller first, see what you end up with when you simplify. Let's say you were multiplying this one by something that looks like it, that's maybe 2 over 3 or something. So instead of multiplying all these x's, you may end up multiplying just 1 over 3 by 2 over 5 or something like that, something simple like this. So you do want to simplify your fractions before dealing with them, before doing anything. All right, so that's for fractions. Now we're going to see examples, actual examples with this, something like this. So, so rational expressions. So we have x minus 4, maybe a number here, and some expression here. 5x is second. And we want to times this by some other expression, maybe 12, x minus 4. And we need to times that by maybe, let's say 10. Say 10 and x to the 5th. Okay, so if you look closely here, this kind of looks like something like this. So what do you think happens now? So before multiplying straight across, what happens now?
Factor.
Okay, try to factor. It looks like it's already factored. So 12 times this. This can't factor. X
minus 4.
What happens to x minus 4?
Are we gonna simplify?
That's right. This cancels out. So You have a common factor, here, just like, for example, 5 on 5 here. What else? We can also...
Then we're going to simplify 3 and 12 and 10 and 5.
That's right. So you see that we have 3 and 12 here. We have 5 and 10 here. We can reduce those. And we also can reduce 10, x over 5, x over 12.
Subtract the exponent? No, right?
We're going to subtract the exponents. Okay, so let's try to do that one step at a time. So we canceled x4 and x4. Let's write the expression. So let's write what's left and then simplify it more. So 3 is left here times this 10x to the 5th. On the bottom here we have 5x to the 2nd times what's left here, which is 12. You could do all the steps here, but it's going to get a little messy and confusing. So I just do one thing at a time. Cancel the common factors. Now let's reduce more. So you can do it any way you want here, as long as you reduce it to the lowest term. So it looks like we can reduce these by, reduce 10 and 5 by 5. Okay, so 5 into 10.
2.
That's right.
And 1.
1.
Here. Then you have 3 and 12. We can reduce by
1 and 4.
1 and 4.
4.
Exactly. There's 1 here. And 3 goes into 12 4 times. And afterwards, we're going to see what to do with x5 over x2. So let's leave that for the next step. So now we have 1 and 2 left here. 1 and 2. That's 2 times 2. We have 1 times 4, which is 4. We can simplify even more. Now we have x5 over x2. Okay, one final step. 2 over 4 is basically 1/2. And what's x5 over x2?
X over 3.
Exactly, x over 3. And you don't need that 1 here, but just for the sake of clarifying. And that's your final answer, which you can say basically x3 over 2. That's the power of factoring and simplifying. We didn't have to factor here, but it was already factored. But we do have to if it's not. As you can see, we didn't even have to distribute or multiply anything because we simplified first. Again, always simplify first. And that's our final answer. We got it from this complex expression simply by reducing it to the lowest terms first. We were left with something much simpler like this. We didn't even have to multiply much other than 1 and 2, 1 and 4 here. Okay, so when multiplying any irrational expressions, reduce first. You may need to factor first. Let's see an example where we probably factor something. Let's say x to the 2nd minus 9. So we want to times this by x to the 2nd plus 5x plus 6. Maybe this. Also something over here, probably 4 or just 2. Maybe actually say 2x plus maybe 4. Okay, so again, looks like there's a lot going on here. No reason to freak out or panic over this. As you can see, once we follow the steps we did earlier, it's going to turn into something much simpler without having to do any actual multiplication. So the operation is multiplying these two fractions. We know the rule, we could multiply it right away. But if you do it right away, it's going to be a lot of stuff, a lot of work, distributions, especially here, 3 times 2 terms, it's going to be 6 terms here, 4 terms, combine, simplify. It's going to be a lot of work. But instead of going through all that, you're going to try to see if you can simplify it into something like this. and only multiply what's left at the end. So instead of multiplying these two large fractions, we reduced them. We only had to multiply these smaller numbers, and we got a simple answer. All right, so as always, so what do you do first?
We're gonna simplify.
In order to simplify, that's
Two. Oh, okay, I thought, okay.
what do you
Factor.
yeah, first. Right. We're gonna factor first. Before we can cancel out or simplify, we're gonna turn this into some multiplication like this. Something like this before we can cancel things out. So we're gonna factor everything here as much as possible using all the rules of factoring. Again, I keep insisting that you need to know your factoring very well. If you need to, you can always review the last couple of lectures before the midterm. We detailed all these methods of factoring, which we're gonna be using throughout this course to do a bunch of things. All right, what is this equal to? If we factor it, a binomial, no GCF, it's gonna be
X minus 3 plus X plus 3.
that's right. So first one done. What about this one? Trinomial, there's no GCF, so we can write it this way. What numbers?
1 and 5.
1
1 and 5. This is not like the previous one. Okay, not exactly like this. This one has 6 and 5. This one is the opposite, 5 and 6. So what numbers multiply?
Oh,
5?
okay. 2 and 3.
That's right. 2 numbers plus 1 plus 3. Times. So we're done with this one. Turned into this. Okay, just factored. We're gonna do the simplifying later. I'm gonna take the second one and do the same thing. How do you factor this? Again, always start with the GCF.
2x plus 2.
What's the common factor here? 2. And times.
X plus.
That's right, x plus 2. Over, what's the common factor here? 2.
2.
And x minus.
X 3.
That's right, minus 3. So that's good. So the stage is basically like this. At this point, we're going to cancel out all the common factors. So what cancels out?
X minus X plus 3, X plus 3.
That's right. Any common factor, as long as it's one from the top against one from the bottom. You can't cancel from the same side. So looks like here, we can cancel the x plus 3, x plus 3. What else?
X minus 3, X minus 3.
That's right, x minus 3, x minus 3 here. And?
X plus 2.
Again, x plus 2, x plus 2. So basically, everything cancels. Just gonna have 2 and 2 left. Right, we have 2 over 2, which is?
1.
1. See, isn't that interesting? All this BS, all this complex expression is basically just 1. Okay, and that's the power and the magic of factoring and simplifying. Are you convinced now that factoring is good and simplifying, or not yet?
Yes.
Okay, do you see the method behind my madness?
Mm-hmm.
Very good. So again, it's a useful tool. We use it all over the place. So this thing again, all this just equal to 1. So if you didn't know factoring, right? If you didn't know factoring in addition to the rules of fractions, you wouldn't get to this answer. But if you know your rules, this can be done in a couple of minutes. If you choose the long way and the complex way, it will take you a long time. You may never get the answer. Okay, so that's basically how you multiply rational expressions. The division itself is not much different. There's one letter trick that we need to do, and basically we get the we just have to turn these divisions into multiplications and repeat the same process that we just did. All right, so before we do division, let's do another example here. sometimes you don't see binomials and trinomials. You just see this, for example. You'll see, let's say, 35 and multiply against some x and y here, and possibly some other number here, maybe some x here, maybe some y here. Okay, so you may get into something like this. So this is a division here, I mean a multiplication. As you can see, this does need to be factored. It's already all multiplications. No need to factor it because it doesn't have binomials and trinomials, basically all monomials. So again, before multiplying right away, let's say we can reduce anything. Please, we can reduce these by 5. It'll be 3, it'll be 7.
And 7.
That's right. And then we can reduce this way. We have power 1 here. So it'll be x3 over x1. We can also reduce these two. We have y2 over y1. So this turns into, so we're not multiplying yet. You're just going to see what this becomes. So we have 7 and 3. x3 over x1, subtract the powers will be x2. Then the y5 stay here. You have 3 here. Then we have x4, which stays here for now.
Y1.
And we have y2 over y1, which is?
1.
That's right, y1. Believe now we kind of simplified as much as possible. Let's go ahead and multiply what's left and see if we can simplify a little more. So let's multiply straight across. Even though you can still, as you can see, you can still reduce the x and x here. You can do it right now if you want, or you could multiply and cancel them out. So let's multiply now this way. So after simplifying, we can do x2. Then we have y, we have 3. So we have x2 and 3. We have y1 times, y5 times y1, which is y6. You add the powers when you multiply. And here is 7 times x4. What's one last step to do here? Here's one last thing. There's one letter thing we need to do here, and we're done.
Can you do the
x2 and x4?
That's right. So
We're gonna have just x2 and y over 6.
So x2 over 4. If we subtract, then it will be -2. 2 minus 4 will be -2 at the top. Then we have to move it down. So it becomes 2 on the bottom of the fraction. Then this y6 stays here. So here we combine a bunch of things, all the rules, not all the rules, but the rules of exponents that we learned before, including division and multiplication. We applied them here. We applied some rules of fractions as well. Not much factor in here because it was already factored, but if it's not, we need to factor it first. And that's your final answer here. Okay, so the key thing here is simplify first. First of all, factor if possible. If not, simplify before multiplying. That's basically a multiplication of rational expressions. Does that make sense to everybody in the room? You guys, any questions before we move on to division? Everyone?
No
From both of you?
No question.
Please ask your questions for now. If you understand anything, if you don't understand, please let me know. So now let's talk a little bit about division. Division, not much different from multiplication. There's one little change we need to do in the beginning, and then I'm going to repeat the same thing. A division of rational expressions. So again, before we do the actual expressions, let's review some basic fractions and divisions. If you have 3/2 divided by, let's say, 5/7, how do you divide fractions?
Two over 3 by 7/5.
You
No?
flipped both. Why did you flip?
Yeah.
AFC.
That's right. Keep, change, flip, right?
Mm-hmm.
Keep, change, flip. That means keep the first one, change the division into a multiplication, and flip the second one. So once you turn this division into a multiplication, then you do the exact same thing as here. So 3/2.
¿Qué pasó?
Patricia, please mute your mic the whole time. You have background noise. Patricia, please mute your mic. Okay, so keep the first one, change the division into a multiplication, flip the second one, 7/5. As you can see now, we can go ahead and multiply straight across. But before that, always try to reduce if possible. Doesn't look like we need to reduce anything here. You can go ahead and say 3/7, 2 times 5, which is 21/10. That's your final answer, you can't reduce. Basically, division is just an extra step from multiplication. Okay, so forget about cross multiplying. We're not going to be using cross multiplying. Instead, we flip the second one and KCF. So there's no cross multiplying. Okay, just forget that. It's easier to turn it this way. Once you see it as a multiplication, it's easier to cancel out, simplify if possible. Okay, so keep that in mind. So we're going to see how to use that. See how to apply that to some actual expressions. All right, so let's make up some problems. Let's say, let's do a second, plus 7x, maybe 12 here. We're going to divide that by let's see, something like 4x plus 12. Okay, and let's see over here, we can use maybe some x to the second, minus 9, and x maybe minus 3. Okay, so we would like to simplify or divide these two rational expressions. So this is probably as complex as it can get. It's gonna be a little bit longer than this one, for example, but again, just remember the main steps. So it's a division of two fractions. What is the first thing you do? So think about fractions in general. Don't get confused with this and all the x's. Just think about the fractions in general. Division of fractions. What's the first thing you do?
So we do this. We do the
Flip,
KCF, we flip
right?
it.
That's right. Keep, change, flip. So you do keep, change, flip. That's the very first thing you want to do when you have division. Don't factor yet. Don't simplify anything yet. You want to do that first. So keep this the same. I'll write it down again. Patricia, again, please mute your mic. You have background noise. It's annoying to everyone in the room. Patricia?
Yeah.
Please mute your mic. We can hear all your background noise. It's very distracting. Okay, so I'm gonna write this first one. I'm gonna write this first fraction here. I'm gonna have to remove you. Okay, keep the first one, which is actually the second. -9, change. That's, we're gonna change this division into a multiplication. Finally, flip. Flip the second one. That's exactly what we did here with the regular fraction. So this will be x minus 3. 3x plus 12. Okay, keep, change, flip. What else? What is the next step?
Then we're gonna factor.
Exactly, so we're gonna factor. Let me write those steps here. Keep, change, flip. Now we're gonna see the factor. So again, once you turn it into a multiplication, we're basically repeating ourselves here. We're gonna do the same thing we did here. So we're gonna factor all this here. What would this be? Two numbers are multiplied to 12, add up to,
Gonna be
what is it?
x plus 3 and x plus 4.
That's right. And over here, it will be
X minus 3. I mean, yeah, x minus 3.
that's the same thing.
Mhm.
And factor this. Looks like it's already factored here, so x minus 3. And here, what is the common factor?
3.
That's right, 3. We have x plus 4.
4. Mhm.
All right, so that's the second step. What do you do now?
Simplify.
That's right, cancel or simplify. Cancel out the common terms. So everything here, anything from the top against from the bottom will cancel out. So what cancels out?
X plus 3, x plus 3.
That's right, first thing here, always start locally in each fraction first before you can cross.
Yeah, because we're gonna simplify everything basically.
That's
X
right.
minus 3.
This cancels out, that's right. And then we have
X plus 4.
X plus 4 cancel out. Also x minus 3, x minus 3. So the whole top here, what's left?
3.
The whole top, the top, not the bottom. So
On
there's always an invisible
1
one. There's always an invisible one here. So we have 1 left over and
over 3.
over this 3 that's left here.
Mm-hmm.
The whole thing turns out into just this 1 over 3. Again, we didn't even have to do any multiplication because we simplified first. So you don't want to waste time distributing all this and ending up with a large expression here, which you will have to simplify and you'll have to factor again and do a lot of things. But always, again, go by these 3 steps. Doesn't matter how complex the expression might look. If you break it down, so you don't have to remember a lot of details here. This is what you need to remember, 3 main steps. And each one of the steps themselves are not that bad. So each one involves some factoring, involves some exponentials or some exponent rules. So this is the big picture, as they say. So you want to remember this. And once you get into each detail, each step, then you get into some more details. But do not try to remember every step. I do this, I do that. No, this is the main thing. And depending on the expression, this applies to all of them. But with factoring, again, always try to find the GCF first. If that doesn't work, then you try one of these three. And that's pretty much how you simplify, multiply, and divide your rational expressions. We're going to learn how to add and subtract next time. Addition and subtraction of fractions involves finding the LCD. So that's for another class. We're going to spend a whole class discussing that. Any questions, any issues about everything that we learned today? Everybody, I want to hear from all of you.
Yeah, it was good. It was okay. I just go back and watch it again to be sure.
Okay.
Me too.